Okay, so find the volume of the wedge in the figure. So I'm seeing the figure here, and this is figure 79 on page 187. By integrating the area of the vertical cross-section. And then it goes on to say, you're given certain information about this figure. And let me put this down for you. So it says A is 6. So this is going to be, looking at it, I want to claim, kind of looking at this, I'm going to say this appears to be the x-axis, and that would continue to go on in that direction over there, by the way. So this is the x-axis. This would be the y-axis. I'm going to erase this in a moment, by the way. And this is like a three-dimensional graph, and this would be the z-axis over here. All right? Now, looking at it, if they're saying that's 6, I'm going to say, well, on the x-axis, that would actually be minus 6. All right? Let me keep reading it. And then it says, the b is 8. I'll write this over here. Now, that's coming out, so it's going to be positive 8. And then the c, it's above, so it's going to be 3. All right? So I got that information over there, and the next thing I got to do is figure out how to get the volume. And the way you're going to do that is with this information over here, something about a cross-section. All right? So looking at it, and the first thing I like to do is get the differential from it. And if I saw that, I'd actually see a box. It would look like this over here. And again, I'm not the best at drawing pictures, but it's sort of like a box that looked like this over here. Where this thing over here, the width of that box would be dx. All right? So let me kind of draw that in over here. And I'm going to say the width of that box is dx. And I'll write this one down for you. So it's going to be minus 6. We're going along the x-axis. Up here, they're stopping there. I'm going to say they stop at 0. And we got a differential dx. And then, I got the width of it. I got this part over here. What I kind of need is I need this information over here. And the reason that I need the area of this, and the area that's going to be 1/2 times the base times the height of it. All right? Well, let's look at this. And what I want to do is just discuss the equation of this line over here. All right, so let's put this down. I'm going to put down y equals. Well, I'm looking at it, and I'm going to say the slope looks like, it's 3 over, the run is 6, by the way, rise is 3, so it's 1/2 times x, all right? And the y-intercept is 3, all right? So I got that down. And then what I need to do is I need to look at this business over here, all right? And I got to get the equation of this line now, all right? So I got two things going for me. I got this, and I got this line over here. And I'm going to say, looking at it, a little more complicated. And I'm looking at this thing. It's not the easiest thing to look at, but I'm looking at the slope of it. And let's take a look at that. That would be 8 over 6. So I'm going to say, z equals 8 over 6 times x. And then the z-intercept there, and it looks strange to you, is just 8. So I got the dimensions of it now. Let me write this down for you. It's 1/2 times the base times the height. This is the base, and this is the base over here in terms of x's, by the way, which is good. And I'm going to say, I'm going to reduce the 8/6 to 4/3 plus 8. And now the height of this thing is going to be what? Well, I got it over here. It's going to be 1/2 of an x plus 3. All right, now certainly my opinion about this is that the integration is probably the worst thing you have to set up. Could you set it up differently than I did? Yeah, you could have, but the bottom line is that's what I'm seeing, all right? What I'm going to do now is I'm going to start to erase things over here that I no longer need. And I don't need the picture anymore. I think I got everything covered. Now, of course, I could get it wrong and then I have to do it again. But what I'd like to do is just look at the key. And I want to see if that's a key as it's written down. And again, you might be surprised that you're not matching a key at this point. And let me see, I got the x over 2. I see that over here. And then I got this business over here. So I'm kind of satisfied with that. So what I want to do is I want to simplify the integrand. Right, I'm going to do that on the side for you. And I'm going to write down 1/2 And then I'm going to write, common denominator here is 3. The common denominator here is 2. And what do you get? You get 4x. And then if it's 3, it's going to be plus 24. All right, I'm just going to go very peacefully and simplify as much as I possibly can. The next one I get 2, and then I get x plus 6. All right, what I'm going to do now is, factor the numbers on the bottom and make it into just, when I shouldn't say factor, but simplify the bottom. It's 12. I'll put this over here. And I'm going to factor a 4 out from the first factor over here. So I'll put a 4 here. And what do you get there? X plus 6. X plus 6. All right? What do you get there? You get 1/3. And then you get x squared plus, put this in parentheses, 12x plus 36. All right? All right, let's take a look at that and see what we have. I'll write this over here. I'm going to pull the 1/3 out. This is minus 6 to 0. And this is going to be x squared plus 12x plus 36 dx. All right, I got to go through the antiderivative over here. And put this one down. It's going to be 1/3. Again, what I'm working towards a goal, and my goal is I'm hoping to see this over here at some point. The antiderivative of x squared is going to be x cubed over 3. Then you get next up, that's going to be x squared over 2, and 2 goes into 12 6 times. Then what do you get? You get 36x. The limits of integration here are going to be from minus 6 to 0. I want to keep moving forward on it. I'm going to multiply it out. That's going to be x cubed over 9 plus, well, 3 goes into 6 2 times, so 2x squared plus 3 goes into 36 12 times, 12x. Limits of integration go from minus 6 up to 0. Certainly, I got to do the arithmetic, but I kind of want to look at this thing now and see, am I meeting a goal over here of getting the correct antiderivative? Well, x cubed over 9, 2x squared, I got the 12x, and the proper limits of integration. What I'm going to do now, plug it in. And what's nice about this, the upper limit evaluates just to 0, because every term is 0, minus the lower, and I'll be careful about this. The first thing I do, cube minus 6, I want to write this down, kind of carefully. It's minus 6 cubed, which is minus 6, minus 6, minus 6, and on bottom there's a 9. So I'm going to say, I'm going to divide the bottom by 3, so I get 3. This becomes minus 2. I'm going to do that again. This becomes minus 2. Minus 2 times minus 2 is 4, and 4 times minus 6 is minus 24. All right, I got that one done. Let's do the next one. The next one's 2 times minus 6 squared. I'll write that over here as 2 times 36. And then it's going to be plus 12 times minus 6. All right, got to do that arithmetic. And looking at it, I hope you realize that, 12 times minus 6, relatively simple. It's minus 72. This is plus 72. These things disappear. What are you left off with? Minus 24, which is 24. We're getting it. Thank you.